Okay, today's lesson is on solving problems with two right triangles, a step up from last lesson where you're solving problems with one right triangle. We're going to start with some easier problems, review angle of elevation, angle of depression, review solving for a side length and an angle in a triangle. But if you're not very comfortable with doing our simple three trig functions, simple three trig inverse functions for solving for an angle and side length of a right angle triangle, you need to go back and complete those exercises before attempting this lesson. So today's learning goal is draw diagrams from word problems involving two right angle triangles and solve for missing angles and side lengths. Exactly what I just said there. So before we get started, we do need to learn some terminology to make sure we're all on the same page here. Angle of elevation measures from the horizontal upwards. So keyword there is from the horizontal. So here is the horizontal, and this right here would be your angle of elevation. Let's say that is 30 degrees, whatever it happens to be. But it measures from straight horizontal from that gentleman's eyesight, and it measures upwards, hence the elevation. Vice versa, angle of depression starts at the horizontal still. So notice horizontal still in that definition there, and it measures downwards. So that angle of depression starts at the horizontal and measures downwards. So that would be the angle of depression or downwards. Let's say that one is 42 degrees, whatever it happens to be. Remember those, elevation up, depression down, pretty easy to remember. First problem we're going to go through, quick one just involving one triangle and making sure you understand the angle of elevation versus depression. So Jane is on the 5th floor of an office building, 16 meters above the ground. She spots her car and estimates it's parked 20 meters from the base of the building. Determine the angle of depression to the nearest degree. Hardest part about all these problems you'll find, or maybe not if you're a better artist than I am, is simply drawing the pictures. Once you have the pictures drawn and you can see where the triangles are, what they're trying to get you to measure, it's not overly challenging, but getting an accurate diagram takes some time, takes some practice. So here you can see my wonderful office building. That is exactly 16 meters. For some reason, Jane is going to be standing on the very top of this building, and she is going to be looking down to spot her car. So if this is Jane standing right here at the top of the office building, let's say she's looking down, and that's the line of sight, that black line there. And she spots her car and estimates it's parked 20 meters from the base of the building. So that diagonal, that hypotenuse I've just drawn right here, isn't 20 meters. She's saying that the car, let's say this point is the car right here, from the car to the base of the building, saying that is 20 meters. For the foreseeable future, all buildings hit that perfectly flat ground at 90 degrees. It's a math problem thing. We can assume that is true. So I'm going to draw my 90 degrees in there. And then we're saying that determine the angle of depression to the nearest degree. So remember that the angle of depression, if this is Jane's sitting up here 16 meters above the ground, it measures from the horizontal downwards. So if this is the perfect horizontal there, this her line of sight going out at 90 degrees, they actually want to know what is this measurement up here. Now we don't really have a triangle there. We could draw that, replicate that triangle upwards, but I know if I know this measurement right here, let's go in a different color here. If I know this measurement right here, I know that that will be 90 degrees, this whole thing right here. So if I simply find out theta, let's call this theta 1 in red, I can just do 90 degrees, subtract the other one, and I will get that measurement. So there's the diagram I have drawn. If I want to simplify that diagram, I can do a simplified diagram off to the side. I know it's really just a right-angled triangle. So if I draw a right-angled triangle, something like this, where I've got 16, 20, and unknown hypotenuse, and this is my angle here. Well, if I just gave you this question, I ignored the rest of the words and just gave you this, it'd be a relatively easy problem to solve. You'd look at this and label your triangle first, realizing that across from your theta is your opposite, beside your theta is your adjacent. So I know that theta is equal to question mark, adjacent is equal to 16, and my opposite is equal to 20. So I'm thinking to myself, what trig ratio uses O and A? Of course, that's TOA. So tan of theta is equal to opposite over adjacent, 20 over 16. And since I'm solving for the inverse, I need to, or solving for the angle, I need to use the inverse. So I'm going to take the tan inverse of 20 divided by 16. Of course, we could reduce that fraction if we wanted to. I probably should have. Of course, you would. You're better than I am. And tan inverse of 20/16 is, let me switch my calculator to tan inverse of 20 divided by 16 is equal to 51.34 degrees. 51.34 degrees. So that's my actual theta on the inside of that triangle. And I'm not going to round my answer significantly yet because I know to find theta, let's call that theta 2, the actual measurement that they wanted, I'm going to have to do 90 subtract what I just found to find the actual measurement that they were looking for, the angle of depression. So I'm going to do 90 subtract my theta 1, which I just found there. I should call that theta 1. 51.34. So I'm going to say that theta 2 is equal to 90 subtract 51.32, and I get the answer of 38.68. 38.68 degrees. Now I do need to read the question there saying they're asking us to round to the nearest degree. So in my therefore statement, I should say therefore the angle of depression is 39 degrees rounded to the nearest degree. So they want the whole degree there. So once again, kind of drawing that diagram off the bat is the most challenging part. Once you get a triangle, you can simply apply our trig ratios to solve for the one unknown. They'll give you two pieces of the puzzle. You got to solve for that third piece of the puzzle. Okay, next one. If you want to push pause, try to draw the diagram yourself, and then just speed up and see if you get the exact same thing as I did. So this one, Kenny's looking at the window of the apartment building and notices a bird on the roof of the nearby building. So I'm going to start my drawing right away. I've got the snap to straight function. Makes my diagrams look a little better than yours maybe. Let's draw a straight line there. And a bird on the roof of a nearby building. So here's a nearby building over here. So let's say this is Kenny right here. Okay, for Kenny. The angle of elevation between Kenny and the bird is 34 degrees. So the bird must be significantly higher than Kenny because he's looking up at an angle of elevation. Let's say the bird just happens to be on the very top of this building. Seems like a good spot for the bird. And we know that the angle of elevation, so I'm going to label this, I have to draw a horizontal line because we know the angle of elevation measures from the horizontal upwards. So this must be 34 degrees here. And then Kenny also notices a friend waving to him in the same nearby building that lives 2 floors below Kenny. The distance between Kenny and his friend is 31 meters. So we don't know what that angle of depression is, but it's 2 floors below Kenny. I don't know, maybe something like this here. And they are telling us that the physical distance, so that hypotenuse, the distance between Kenny and his friend is 31 meters. So I can label the length of this line, 31 meters. If the 2 buildings are 25 meters apart, so from here to here, is 25 meters apart. How far apart is the bird from Kenny's friend. So they want to know this total distance from here to here. What is this total distance from there to there? So we have to sort of dissect this and get our two right angle triangles in here. We can see that the distance between these two buildings, that's also going to be this line here. This is a fictional line. It's just a horizontal line coming out straight out from Kenny. But it's going to help us a little here. So first thing I'm going to take a look at is this bottom triangle. So this triangle going from here to here to here. I can label this point on the far side. Let's label this F for friend. And this is just, let's call it C. It's the center on the opposite side. Well, this triangle is going to be a right angle triangle because we assume all buildings are perfectly straight in math problems. And we can see one length of the triangle is 25 meters. The hypotenuse across from the 90-degree angle is 31 meters. So just to simplify it a little, I'm going to draw this triangle on a smaller scale off to the side so you can see exactly what I'm talking about. But if you look at this triangle here, we've got C, F, and K for Kenny. We know that this is 25. It's the distance between the two buildings. That's 31, distance from Kenny to his friend. So if I just gave you this problem, hey, this is a pretty easy problem to solve. How would you solve for that side? A couple different ways. I'm just going to use Pythagorean theorem. So a squared plus b squared is equal to c squared. B squared is equal to c squared. Very important that c, that has to be your height. So no matter what I happen to label it C here, so it worked out perfect that, side C is C, but that a side on the far side of the equal signs needs to be your height. A and B don't really matter. I'm going to call this one 25 squared. I'm going to pretend we don't know B, and C squared is 31 squared. So if I isolate for B squared, I've got 31 squared minus 25 squared. So B is going to be equal to the square root of all that. 31 squared minus 25 squared is 336. Square root of 336 isn't a very nice number. Because I'm in the middle of a question, I don't want to round to the nearest meter. I want to keep it somewhat accurate. If the question doesn't explicitly say, keep at least 2 decimal places. So I'm going to keep 18.33 meters. It's not perfect. I did have to round a little there, and you'll notice in these two-step questions or these two triangle problems, you often have to round mid on one triangle and then use it in the next triangle. So try to keep a couple decimal places there, at least to the nearest hundredth. So we found out the distance from just here to here is 18.33 meters. So we've solved for a small chunk. Next, we want to find out this next distance from here to here, because if we find this distance, we can add it to 18.33, and we will have our total distance. So next, I'm going to look at this second triangle from here to here to here, and use the information required. So if I draw this one off to the right in red to make it a little more simple here, if I just gave you a problem that had one triangle, looks something like this with a 34-degree angle, a 25-degree side, and I said solve for that, how would you solve this problem knowing that this is Kenny, this is the bird, and this is the C, the center point on the opposite side? We could just use our trig ratios. Label our sides. This is opposite our theta. This is adjacent to our theta. Looks like we're not using the hypotenuse here. So I would use something that, a trig ratio that uses O and A. So I'd use tan. I know that tan of theta is equal to op over hyp. Not hyp. Op over adjacent. And tan of theta, and this happens to be 34 degrees, is equal to op. I don't know what that op is. I'm just going to leave it as op, or I could write x there. Might be a little more formal. Divided by the adjacent, which is 25. Now I want to isolate for op, so I'm going to multiply both sides by 25. and that's going to divide to 1 there, and we're going to have isolated for opposite on this side. And on this side, we've got 25 times tan of 34 degrees. So we can solve for this one, and we can say that's 25 times tan 34 is equal to approximately there. Pull out your scientific calculator, make sure you're in degrees, 16.86 meters. So I've got a value of 16.86 meters. So then if I want to find the full distance, so I'm actually looking for this full distance. If this is 16.86, I know that BF, the full length from B to F, is equal to BC, what we just found, plus CF, I guess that is. So we're saying that is going to be BF is equal to 16.86 meters plus our other measurement, 18.33, equaling to 35.19 meters. So you can see the question doesn't tell us what to round this to, so I'm going to round to 2 decimal places, round to the nearest hundredth, just to be on the safe side. Okay, next question. Once again, pause it, try to draw the diagram, solve it, and then click play and fast forward to where you need to see if you got the same answer I did. Standing in front of a 15-meter tall building, you look up at an unknown angle of elevation to see the top. So I'm going to draw my building here. Beautiful looking building. And I'll try to draw a horizontal line-ish. Remember, all buildings are on flat ground in math problems. So this is you. You are standing in front of 15 meters in front of a building. So from you to the start of that building is 15 meters. That whole thing there. I'm just going to say this whole thing is 15 meters. And when you walk 10 meters directly towards it and you look up at the same angle, you see a window that is 6 meters below the top of the building. So let's see here. If I look up at this angle to start, we'd call that theta. Then I walk 10 meters closer to the building. So I walk 10 meters directly towards it. So this little chunk here is 10 meters. Maybe just to scale, I'll draw that a little more accurate. That is theta. 10 meters here. And we look up at the same angle. So we'll try to draw that as parallel as possible to that other line. This line is parallel to this line. So that means that that theta is the same as the other theta. And that must be 5. 10 plus 5 is 15. And we see a window that is 6 meters below the top of the building. So that must mean from here to here is 6 meters. Here to here is 6 meters. So we have a diagram that's somewhat convoluted. We can kind of see the 2 triangles that are forming here. And if we take a look at the bigger triangle first, so I'll highlight the bigger triangle. So here's one nice right angled triangle. Of course, buildings hit the ground at 90 degrees. We can put our 90-degree symbol in there. And we can say, okay, if we label the sides of this triangle, you know, opposite theta is our opposite. We don't know how big that side is. We do know that chunk is 6 meters, but there's some unknown distance right here. So it's going to be 6 plus some unknown distance. I'm going to go ahead and call that x for no particular reason. So I've got my opposite over there. I've got my adjacent down here. So if I want to use a trig ratio that use opposite and adjacent, I can say that tan of that angle, theta, is equal to my opposite. My opposite is 6 plus x, and that's all divided by my adjacent, all divided by 15. Notice here I have two unknowns. I've got theta. I don't know what theta is. We're trying to solve for this angle. But I also have this other unknown, x. I can't solve one equation with two unknowns. If I want to solve this equation, I'm going to have two equations with two unknowns. Then I can do a little substitution. So I'm going to take a look at my smaller triangle as well. If you've noticed the smaller triangle in here, this triangle right here to here to here, we also could have a tan theta. So I'm going to make an equation using this smaller triangle. So I'm going to say tan theta, the opposite in this case is just x, and the adjacent in this case is just, if I say adjacent and up of the smaller triangle, is just 5. So here you'll notice I also have two unknowns, right? I've got an unknown of theta, same theta as before, and I've got an unknown at x. Two unknowns, one equation. I can't solve for one of those equations on their own, but I can do a little substitution, saying sub 1 into 2. So if I do a little substitution here, I see that tan theta and tan theta are in both of these equations. Tan theta and tan theta are the same thing, right? That theta needs to be the exact same angle because we're looking up at the exact same angle. So if I sub 2 into 1 or 1 into 2, doesn't really matter how you think about it, 6 plus x over 15 is equal to tan theta, but tan theta is actually equal to x plus 5, or x divided by 5. So I have got one equation with one unknown now. X is my only unknown there. So I'm going to multiply both sides by 5 to get rid of the 5 on this side. So I'm going to have 5 times 6 plus x, and I'm going to multiply both sides by 15 to get rid of the 15 on that side. So that's going to equal to 15 times x, just to get my denominators out of the denominator there. So I've got to do a bit of distribution. If you're an arrows man, draw on your arrows. 5 times 6 is 30. 5 times x is 5x, is equal to 15x. Now we just have to isolate for our variables here. Bring the 5x over to that side. We've got 30 is equal to 10x, or x is, divide both sides by 10. We've got x is equal to 3. It's not what the question was asking us. It didn't want that measurement there. It wanted the actual angle of elevation we were looking at. But we can use that to solve for the angle of elevation. So if x, we go back to our diagram, is 3 right here. We've since found that out. We can look at that smaller triangle. If I redraw that smaller triangle out again, here we go. If I gave you this problem that simply had 3, 5, and theta, and I asked you to solve for theta, how would you solve for this one? Well, it's using our opposite and adjacent again. So if you label your sides op, adjacent, you're subbing it back into that original equation. We're saying that tan of theta is equal to opposite, 3, divided by adjacent, 5. If you want to solve for an unknown angle, you have to use the inverse trigonomic function of tan. So we're saying tan inverse of 3/5 will be equal to that angle theta. Thus theta is equal to 31 degrees. I should write out a couple more decimals. 30.96 degrees. And it doesn't ask us what to round to. I'm just rereading the question there. What angle of elevation were you looking at? It doesn't ask us what to round to, so I'm going to leave 2 decimal places just to play it safe there. Therefore, the angle of elevation is 30.96 degrees. Any questions on these? Feel free to email your teacher or ask during class. I'm going to move right along to the next one here. Question number 4. Once again, pause. Try to draw out this diagram, solve for one or two things. Once you get stuck, hit play, fast forward to where you're stuck. So standing on a street, you see a fire break out of the roof of a building. A lot of buildings going on here, standing in front of buildings in these questions. I'm going to draw out my building, give or take here. Beautiful straight building. Of course, it hits this ground at 90 degrees, as all these questions do. You see a fire break out on the roof of this building, an angle of 75 degrees. So let's draw us a pretty steep angle, so we must be standing pretty close to this building. And we've got a fire up here. So this whole angle is 75 degrees because angle of elevation goes from the horizontal upwards. Lower down, you see a person in a window at an angle of 65 degrees. So I'm going to have to splice this angle I just drew. So I'm going to draw in a different color so you can kind of tell the difference. So let's say this wonderful drawing right here, that is exactly angle of elevation of 65 degrees. So red goes to red, black line goes to black line. The direct distance between you and the fire is 5 meters more than the direct distance between you and the person. So amongst all this chaos, you had a lot of time to measure out the distance between you and the fire and the person. So if the distance between us and the person is x, I'm going to say that red line is x. Maybe I should do that in red just to clarify there. That is x here. Then the distance between us and the fire is 5 meters more. So then this black line up here is going to be x plus 5. We don't know the full height of this building, and we don't know how far away we are standing from this building. So this full height, I'm not sure. H for height. And we also don't know the distance we are standing away from this building, which is going to get a little more complicated because we don't know those two things. So if we take a look at this, we can say that, let's take a look at the smaller triangle first. So I'll highlight the smaller triangle in red. Oop. So if I just gave you this problem here, a little convoluted because we don't know the distance and we don't know the height on the far side. So I'm going to use the two measurements I have here. I'll do this one in red and say that, okay, if I just gave you this triangle, let's draw it out below so we can see what's going on. Distance x and 65. Well, I don't know that opposite side, so I'm going to label my triangle as this is going to be the adjacent, this is going to be the height. Well, I guess what trig ratio uses the adjacent and the height is SOHCAHTOA. So I could say cosine of my angle of 65 degrees is equal to my Ka A divided by H. In this case, A is this physical distance I'm standing away from the building, and my hypotenuse is that X measurement. I'm not too sure what that is yet either. Okay, it doesn't seem like a huge help because once again we have two unknowns in this equation. We have a D that's unknown and an X that's unknown. We can't solve one equation with two unknowns. So I'm going to have to create another equation. So you can probably guess where I'm going to go with this. Take a look at our second triangle. So our second triangle, let's highlight that one just in case you didn't see it. Let's go in orange, is this bigger triangle here, going from here to here to here. Now I do have a H in this triangle, the total height, but because I know my smaller red triangle used D and X, I'm going to try to use the same two variables there, D and X, so I can substitute one into the other, just like we did in our last question. So this triangle looks something like this, where we have D, we have X plus 5, and we have angle of elevation of 75 degrees. And right angle triangle there, of course. So if I wanted to find out an equation for this triangle, I would say, okay, my D is my adjacent, my x plus 5 is my height, my hypotenuse, and we are going to try to use a trig ratio that uses a and h, once again using cosine. So cosine of 75 degrees is equal to D adjacent divided by h hypotenuse, which is x plus 5. Looks a little more convoluted here, but we can make an equation isolate for D. If I have isolated for D in both of these equations, notice there's, switch that to highlighter. Notice there's a D here, there's a D here. If I isolate for D in both of those equations, I can substitute one into the other. So in red, I'm going to say, okay, this is the same as saying multiply both sides by x, multiply this side by x, and we can say that x times cos 65 is equal to D. I'm going to call that equation 1. And then I'm going to do almost the exact same thing in equation 2 and say, okay, I'm going to multiply this side by x plus 5. It's a little bigger, a little uglier, but make no mistake, we can still do it. Times that side by x plus 5. And I'm going to have the equation x plus 5 times cos 75 is equal to G. And well, guess what I'm going to call that equation? Equation 2. So I've got equation 1, equation 2. They're both isolated for G. I can do a simple substitution here. Let's do it in blue. And say sub 1 into 2. Of course, you put a nice title, let the reader know what you're doing. And I can say x times cos 65 is equal to x plus 5 times cos 65, which looks big and ugly, but we can distribute this and we can solve. You could type in cos 65 right now and you could get a decimal for it, and you're going to have to round your answer. So I'm going to show you the most exact way to solve for this without having to write out cos 65, whatever that decimal is, 4 or 5 times. So x times cos 65, make no mistake, cos 65 is just a decimal. Like this is like the exact same thing as saying like 0.6 or 4266x. I just don't want to write out that decimal and round it. So I'm going to expand this. If you're an arrows man, draw on your arrows. And I'm going to keep it exact the whole way. Cos 65 plus 5 times cos x. Cos 65. And I want to solve for x. So I'm going to bring all my x's to one side, and I'm going to bring the other numbers to the other side. So I'm going to have cos 65 times, sorry, this shouldn't be 65. I made a mistake in here, didn't I? That should be 75. Hopefully someone else caught me there. It was going to work out to 0. I was wondering what I had done wrong. So that should be 75, taken from right here, 75. That should be 75. And that should be 75. There, that looks a little better. So we're going to have x times cos 65 minus x times cos 75 is equal to 5 times cos 75. So 5 times cos 75, it's just a decimal, it's a number. I know it looks ugly because there's cos 75 in it, but just a cos 75 is a decimal. Once again, I see something common between both of these terms, so I'm going to greatest common factor out an x out of both of these terms. And I have x times, that would have been cos 65 here, minus cos 75 there, is equal to 5 times cos 75. So a little bit of factoring going on here, nothing too crazy. This is a multiplication, so I'm going to divide that by both sides. So my final answer for this is going to be 5 times cos 75 divided by cos 65 minus cos 75. And we have to throw that into your calculator. I can't do that one in my head. And let's see if I can remember that. 5 times cos 75 divided by 65 minus 75. 5 times cosine of 65 end bracket divided by, calculator went a little wonky there, 65, bracket that, and I want this whole thing to be divided by, cos 65, cos 65 end bracket minus cos 75. So I can type this all into my calculator at once, and I get the answer of 12.9. I'm just going to double check I typed that in right. Cos 65, cos 65, cos 75. Oh, I should have a 75 on the top there, not a 65 on the top. I'm going to change that to a 7. And I get the answer of 7.900497036. Because we're in the middle of a question, I'm going to try to keep a couple decimal places there. So I'm going to keep 7.901. Just because I'm halfway through a question, I don't want to fully round that. So that is 7.901. I understand we have round this ever so slightly, so it's not a 100% perfectly accurate answer, but we do need to use that to solve for the next step. So that's why I'm going to write it out. I suppose I could use this as my exact answer. This would be my exact answer, and I could substitute that into my next one. But for argument's sake, I'll let you round to the nearest hundredth or thousandth there. Just try not to round to the nearest degree or a tenth of a degree, because then you are rounding quite a bit. So that is x. X is our 7.901. So that is our x measurement right here, 7.901. And let's go back and reread what the actual question was asking for. How tall is the building? So it wants this full height here, this full height. So if I redraw out that full big orange triangle, let's do it in orange this time. And I say that, okay, coming from up here, if I gave you this triangle that looks something like this, like this, like this, and we know that this measurement is x, so x plus 5 is going to be 7.901 plus 5. This is going to be my height, and in orange is our 75 degree. So if I gave you just this question, it'd be pretty easy to solve using our trig ratios. Of course, you label your sides. My height is my opposite, so that side would be my opposite. This would be my height, my hypotenuse. So we could go ahead and solve using our trig ratio that uses O and H. Which trig ratio uses O and H would be so. So sine of 75 degrees is equal to opposite, which is unknown. That's what we want to solve for, divided by 7.901 plus 5. I guess I could have just wrote in the actual number there. So then we have 12.901 times sine of 75 degrees is equal to my opposite. And once again, throw that into your calculator there. .901 times sine of 75 degrees is equal to 12.4614. I'm going to round that to the nearest hundredth for a final answer, so 12.46. 12.46 meters would be equal to our height, our final height. That's what the question was asking for. So a couple steps in that one. I do 1, 2, 3, kind of 4 steps in that question. They're getting a little bigger, getting a little more challenging. This next one I'm going to set up for you. I'm not going to solve for you. So I'm just going to set up the diagram so you can kind of see the steps that you have to solve. Then I'd like you to do this one independently, and of course just ask your teacher if you get stuck. It is a little tricky. Might take you a minute or two to find. So a flagpole has 2 guide wires attached to the very top. So I'm going to draw my wonderful flagpole here. And of course we can assume flat ground, as we always do for these math questions. That didn't look very flat for the ground. And one angle of elevation of the wire is 55 degrees. The other angle of elevation is 65 degrees. So obviously if you have a steeper wire, it's going to be closer to the actual flagpole. So that's going to be my 65 degrees, a little steeper angle of elevation, whereas the other one attached to the very top of the flagpole only has an angle of elevation of 55 degrees. 55 degrees. So it's not quite as steep. So one wire is 5 meters longer than the other. So clearly my longer wire needs to be on my side that has my more shallow of an angle. So I could label this one right here x plus 5 because it's 5 meters longer than x. So we've got a 90-degree triangle here, a 90-degree triangle here. I can highlight those for you there. So you're going to have to work with your blue triangle, and you're going to have to work with your orange triangle. You're going to have some unknowns in there. Your unknowns are going to be x, and let's call this h. They both share a common h. They both share a common x. So if you set up 2 equations, one equation for the blue triangle, your second equation for the orange triangle, you'll notice they both have an x, they both have an h. I'd use your sine ratio, looking at that real quickly, use your sine ratio, and solve for your unknowns, or isolate for one unknown, sub equation 1 into equation 2. That'll be my hint. Can you please complete that one, and we'll have a discussion about it in class. Thank you very much.